Hello, biologists. I hope you're having a good day. We have Parker here and then Maxie right here. So we have both boys that are going to help us with our study session today. All right, let's study for the final. So the first thing I want you to do is think about your favorite way to study. Remember back in 221 in fall term, we had those homeworks. In those homeworks, there were several different types of study techniques that you might want to check out if you want to open up those homeworks again and review them. But really, my advice for you is study early, study often, and please take breaks. Make sure to be taking care of yourself. Drink water, have snacks, hang out with your cats. And let's get into it. So I've already sent you an email with a study guide. This is more of things to think about. So I'm just going to pose some questions for you that might be nice to study. You know, there are essay questions on your final exam. And then I'm going to give you a link to a Jeopardy that's going to have practice short answer questions. So the first practice essay question is based on some graphs. I'm going to show you two graphs from climateanalyzer.org. This is real-time data about climate and climate change. And each of these graphs, I want you to ask yourself, what is the independent variable? What is the dependent variable? And what is the overall trend? Because scientific design and thinking like a scientist is one of our major outcomes for this series of biology classes. So here is our first graph for you to check out. Pardon me. This is our first graph for you to check out. This is daily sea surface temperatures. We have a whole lot of lines here. I'm going to go over them and it's going to give you the date. So this is 1985. It has the average temperature right there, 19 degrees Celsius. And then as I go sideways along this line, it will show me the fluctuation for that year based on the month. So that's what's happening. So I'm going to stick right at the end of June here before July, and I'm going to go up so you can see it. So remember, what is the independent variable, the dependent variable, and the trend? Here on the y-axis, I have temperature in Celsius. Then I have the month, and I have the years. This is a legend, though. This is not correlated to the lines on the graph. This is just showing you what color their line is. And if you wanted to look at that year, you could poke it, and that year would show up. So here we go. 1985. Orange line, 2005, 2004, 2003, and this red line here, this is this year. Independent variable, that is the thing that we are changing. We are changing time. Dependent variable, that is the thing that we are measuring. We are measuring the temperature in Celsius. So that's the dependent variable. And what are the overall trends? If we go down to the lower part of the graph in the 80s, we see that these lines are a lot lower. We go to the 90s, we see that these gray lines are much lower. When we start to get into the 2000s, we're creeping above that first dotted line. And here, 2020s and higher, we are above those lines. So overall trend, it is getting warmer in the sea. Here's another one for you. This is the extent of sea ice, daily extent of sea ice. It's a similar setup, but now those bars are not on the y-axis over anymore. They're on the x-axis on the bottom. Ask yourself what the independent and dependent variable. Independent, again, is the time, the year, and the month. And then dependent is what we're measuring. This is areal extent greater to equal to percent of 15 cover of ice in kilometers squared, million kilometers squared. And we'll go through. Here is 2026, 2025. Then we're going to go backwards in time. 2023, 2022, 2021, 20. And then here are the teens. Can you see them lighting up? And you have the website for this if you want to play with this yourself. Here's the early noughts. Now we're into the high 1990s, low 1990s, 1980s, and 1978. What is the trend we saw? Older years are higher. That means that there was more sea ice. More recent years are lower. That means that there is less sea ice. All right, let's go back to our practice essay question. So that's something for you to think about using this data. Please explore it, play with all the different graphs on there so you can practice thinking about variables. Now I want you to think about climate change. You watched several episodes of Weathered, and I want you to practice, maybe for an essay question on your final, explaining what the greenhouse effect is, what greenhouse gases are most abundant, what greenhouse gases are most potent, and those are not the same thing. So it's not just carbon dioxide for each of them. We have the potent and the abundant being different. And then what immediate impacts of climate change are we going to see? Listing 5 and explaining them would be a really nice way to practice for this essay question. I do think it'd be worth your time to physically write it out. I would write it out by hand because I know that that keeps information in my brain better than typing, but maybe you're a typing fan, that's great. Go ahead and type it out like you're answering in a paragraph so you can practice thinking of an answer and verbalizing it through your fingers. I want you to think about what type of threat to biodiversity microplastics would fall under, which general category it would be. And then I'd like you to list and explain 3 other threats to biodiversity. I'm calling out microplastics specifically because they've been in the news a lot, but in general, being able to describe what's going on with biodiversity loss and what's causing it, that is our goal for this essay question. Type it out, write it down, practice making a full answer for this. I want you to think about nutrient cycles, specifically the carbon cycle and the nitrogen cycle. Those are 2 that are severely important for plants, and we love plants. And we know that the carbon cycle is really important because it relates to carbon release and climate change. And the nitrogen cycle is really important because it releases fertilizers and then relates to eutrophication. So practice both of those, please. When I say biotic players, for the carbon cycle, that's definitely going to be us. We are impacting carbon levels. And for the nitrogen cycle, I want you to think about those nitrogen fixing bacteria. So for each of those answers, the full pathway and the major reservoir, I want you to identify both. Then we have 2 sayings. We had a lab based on these ideas. We say in ecology that nothing exists in isolation, and we also say that change is the only constant. I'd like for you to think of specific examples that explain what these things mean. For nothing exists in isolation, you could talk about coevolution, you could talk about symbiosis, you could talk about niches and competition, you could talk about different types of mimicry, warning coloration, trophic cascades. There's so much that relates to this overall idea. And change is the only constant also has a lot that you could relate to it. So there isn't one right answer. You could really connect almost anything that we've talked about to these concepts. For change is the only constant, I think I might talk about microevolution, the Hardy-Weinberg theory, macroevolution, speciation, extinction are different types of species concepts. We could talk about how succession occurs, how disturbance happens in an ecosystem and resistance to that disturbance. You could talk about the biodiversity stability hypothesis, all those cool things that we've learned about. You could even talk about invasive species because we just watched a couple of videos of that, or the impact of climate change. All of those are going to have an effect and would be great for this practice essay question. But really what I want you to do is take all the information and tie it together related to these 2 ideas so you can practice verbalizing. I keep saying it because it's important. Practice is so important. And then lastly, I have a link for you here. This link leads you to a Jeopardy that I created for you. This is what it looks like. So you'll come to this Jeopardy using this link and you'll hit play, and then you get to choose your Jeopardy questions and the point value. This is just for funsies. This is just for practice, but I did write these questions thinking about your exam. So they will be related to your exam content. For example, climate change for 300 points. Annual atmospheric carbon levels fluctuate in a distinct sawtooth pattern. This is primarily because of, and then you can scroll down. This is the sawtooth pattern here. So this yellow line that's going up and down seasonally every year. What's the cause of that? And then you can see there's controls up here. So to continue, hit escape or reveal correct answer, hit spacebar. Spacebar, photosynthesis. So we know that when it's summer and spring in the northern hemisphere, where most of the plants are, plants suck in carbon dioxide to create sugars, and that creates the dip in the carbon dioxide level. And then when they lose their leaves and go dormant, so fall and winter, they are not absorbing as much carbon dioxide, and we have that increase in carbon dioxide level. So this sawtooth pattern here is because of photosynthesis. It's because of growing seasons for plants. So that would be 300. I hope you go through and look at all of them because I think it's fun and I think it's a nice way to study. Let me know if you have any questions and we will chat soon. Bye.